Now, good evening to all. Say, today we are starting one of the important topic, vector algebra. Actually, with respect to EAMCET point of view, or JEE mains point of view, or I can say advanced, or WIT, or SRM, all exam purposes, all sets will say, all common entrance examination, vector algebra and three-dimensional geometry are most important, because in other chapter they will give one or two, one question, but in this chapter and 3D together they are giving 3 to 4 questions, and they are interrelated also. Today and tomorrow, 2 days I am taking the part 1, part 2. Vector algebra part 1 today I am starting. It's I will tell almost all the important formulas, because in the JEE means particularly many times they asked formula based problems also directly. Direct formula based also they asked. So we will do the formulas also and the major problems also, and tomorrow all typical problems also. All major methods of vector algebra I wanted to complete in 2 days, today and tomorrow. So now this if we take a vector is a physical quantity. Vector is a physical quantity having magnitude and both direction, that we know. And always a vector which is measured from a fixed point is called position vector. Is called position vector. So if I take a vector OA bar, let us imagine we can write it as xi, yj, zk. This is a general notation. Or r bar is equal to xi, yj, zk. This is called as a vector. So, or you can say I cap, j cap, k cap, because we'll write like this bar also. So now, if I take ijk are unit vectors along the xyz direction, so a vector general representation is OA bar equal to xi, yj, zk. Now, its magnitude, if I take modulus root of magnitude of OA bar is nothing but root of I cap quotient, j cap quotient, k cap quotient, or x square, y square, z square. This is the magnitude of OA bar. Next important thing you have to remember. A vector with magnitude 0 is called null vector or zero vector. Null vector or zero vector. Next point. If I take A bar, B bar are two vectors represented by two sides of a triangle. A bar, B bar are two vectors represented by two sides of a triangle. Then the third side drawn in opposite direction is called resultant. Or you can say this is resultant is nothing but A plus B. A plus B. So next, that means with respect to this, if I take many number of vectors, one vector, second vector, third vector, fourth vector, if different vectors are represented by different sides of a polygon, the last side or closing side drawn in opposite direction. Last side or closing side drawn in opposite direction is a resultant vector. This also one more point you have to remember. This is called polygon law. This is called triangle law. So why we are doing this means, with respect to mathematics point of view, by using triangle law vector, AB bar is second letter minus first letter. OB bar minus OA bar. For that reason, I wrote the theorems. So our purpose is to do the problems of the competitive exam like EAMCET, mains, advanced, sets, different sets like Geetam, SRM, WIT, etc. For that purpose, because formula based also important, many formulas are there. I am not taking 1 day, I am taking 2 days in the vector algebra. First 10 minutes it will take the all formulas. Next I will start the problem. First 10 minutes I am writing about the formulas. Now, AB bar is equal to, by from triangle of vector, it is OB bar minus OA bar. OB bar minus OA bar. That you have to remember. If I write to get idea, PQ bar means OQ bar minus OP bar. First thing you have to remember. Next, another point is all vector algebra points or vectors or position vector will follow coordinate geometry also. Let us imagine OA bar is a vector, OB bar is a vector, then midpoint of line joining OA and OB. Midpoint of line joining OA and OB is nothing but OA bar plus OB bar by 2. Midpoint of line joining OA and OB is OA plus OB by 2. Next point. Another point if we take, this is a triangle. Centroid is G. Triangle, centroid is G. Then OG bar is equal to OA bar, OB bar, OC bar by 3. Centroid of a triangle. OA plus OB plus OC by 3 is centroid. Next. A bar, B bar are adjacent sides of a parallelogram. A bar, B bar are adjacent sides of a parallelogram. Then this is called principal diagonal, this is called other diagonal. One diagonal is A bar plus B bar, another diagonal is B bar minus A bar. So, adjacent sides of a parallelogram are A bar and B bar. Then one diagonal is A bar plus B bar, other diagonal is B bar minus A bar. Next point. The line A and B are two different vectors. And the C is a point which divides in M1 is to M2. C is a point which divides that line join of AB in M1 is to M2 internally. Then we can write M1 into OB bar plus M2 into OA bar by M1 plus M2. Very leisurely I am telling because formulas are also important. First 15 minutes I will tell only formulas. So M1 into OB plus M2 into OA by M1 plus M2 internally. Externally means here minus will come, here minus will come. Externally means. Now, next thing, another very important because many times they ask. A regular hexagon A, B, C, D, E, F is a regular hexagon. If this is A bar, A, B, C, D, E, F is a regular hexagon, this A bar, this B bar, then this will be A plus B. That will be A plus B. And always opposite to this. This is the side B bar, this is opposite. Opposite will be double the vector. Diagonal opposite to the given side will be double in a regular hexagon. From this, any sides we can find out by using the triangular vector. This is another important point. Next point. Internal angular bisector. Internal angular bisector. A, B, C. This is an angle. This divide the opposite side. This is an angle A. Angle divided into two parts. An internal angular bisector divide the opposite side in the ratio of adjacent sides. Means D divides BC in AB is to AC. One of the most important. Internal angular bisector AD divide the opposite side BC in AB is to AC. This is the another point. Next point. If I take a median AD, in a triangle ABC, median AD will be opposite this AB bars, adjacent side, sorry. So you know, one time this problem directly asked in the mains, one time this problem directly asked in the mains and EAMCET also. So direct formula, they have given AB, they have given AC, they asked the length of the median through A. Through A, median is AD. So AB plus AC by 2 modulus. That is called length of the median. So next point. Now, next formula is a line, a vector equation of a line, passing through A and parallel to B. whose position vector is A bar. I will repeat. Vector equation of a line through A. This is the line through A. Whose position vector? Position vector is nothing but which is measured from a fixed point. So vector equation of a line through A, whose position vector is A and parallel to B, is nothing but R equal to A plus T. There is a line through A and B. Whereas vector equation of a line through A and B, R equal to 1 minus T into A bar plus TB bar. This is the vector equation of a line through A and parallel to B. Whereas this is the equation of a line through A and B. This is the vector equation of a line through A and B. Next point. Vector equation of a line through A, B, parallel to C. Vector equation of line through A, B and parallel to C is equal to R equal to 1 minus T into A plus TB and also parallel to C. So SC. Because line through A and B is this, but parallel to C. Next, vector equation of a plane. Vector equation of a plane is nothing but R bar is equal to 1 minus S minus T into A bar, SB bar, TC bar. This is the vector equation of plane through A bar, B bar, C bar. Always remember, I am writing the all major formulas of the vector algebra for the first 15 minutes, then only I am going to the problems. Because formula based also they are asking. And all the problem what we are discussing, because it will take actually 1 month. But major topics I will discuss, major problems I will discuss, and further problems I will send you by WhatsApp. Those who are interested, they can WhatsApp me all the important assignments, all the important worksheets of the vector algebra I will send by WhatsApp from tomorrow onwards. Now, vector equation of the line through AB and parallel to C. Vector equation of the plane passing through ABC. Now, the next is everyone know in physics also, that is a dot product and a cross product. A bar and B bar are two vectors. Then A dot B is equal to mod A, mod B cos theta. A and B are two vectors. Then A dot B is equal to mod A, mod B cos theta. This is called dot product or scalar product. Whereas A bar cross B bar is equal to mod A, mod B sin theta. This is called as vector product or cross product. This is called dot product or scalar product. This is called vector product or cross product. Next point. A bar is cannot be equal to mod A bar. A vector cannot be equal to its magnitude. A vector cannot be equal to its magnitude. But A bar square is equal to mod A square. But A bar square is equal to mod A square. Next point. Another thing is A bar dot B bar is equal to 0. A bar dot B bar less than 0. A bar dot B bar greater than 0. A bar cross B bar equal to 0. A dot B is equal to mod A cross. If you take the previous entrance papers, competitive exam, all the formula based problems are there, many. So A dot B 0 means A is perpendicular to B. A dot B less than 0 means obtuse angle between A and B. This is acute angle. A cross B 0 means parallel or they are collinear. A cross B 0 means angle is 0. Here angle is 90. If mod A dot B is equal to A cross B, then theta is 45. Mod or A dot B, both are same because it's scalar. A dot B is equal to A cross B, theta is 45. This is another thing you have to do. Now, another 5 minutes it takes for the formulas, then I will start the problems. So next point is, if there is a vector A bar, there is a vector B bar. I want orthogonal projection of A on B. This length, they are asking this. Orthogonal projection of A on B is nothing but A bar dot B bar into B by mod B square. This is also called vector component of A on B in the direction of B. A on B in the direction of B. Whereas if you want length of the orthogonal projection from A on B, this you take it out. This is the length. Next point. Another thing is, this is a cube. This is a cube. If you take in this cube from here to here, it is called diagonal of a cube. From here to here, it is a diagonal of a cube. So, angle between two diagonals of a cube is cos inverse 1 by 3. Angle between two diagonals of a cube is cos inverse 1 by 3. This is called diagonal of a face. So, angle between two diagonals of faces, this and this, is cos inverse root of 2 by 3. And that is diagonal of a cube. I will change it. It's diagonal of cube and diagonal of face. Not this. This one. Diagonal of a face and diagonal of a cube. I will repeating again. One is diagonal of cube. Another is diagonal of cube is this. One is diagonal of cube. Another is diagonal of face is cos inverse root 2 by 3. Both are edges. If both are edges, then cos inverse 1 by root 3. These are the things of angle. You have to remember. Another point also there, in inter, there is a big derivation also. If a line is there, and which makes alpha, beta, gamma, delta angles with 4 diagonals of a cube. Alpha, beta, gamma, delta are 4 diagonals of a cube. I am repeating again, if a line is there which makes alpha, beta, gamma, delta angles with 4 diagonals of a cube, then I will repeat again, a line is there which makes alpha, beta, gamma, delta angles with 4 diagonals of a cube, then this is the 4 by 3. If it is sine square alpha, if I take, it is nothing but 8 by 3. This also you have to remember. Now, coming to last part of the formulas, it is called triple product. Triple product. So A dot B cross C is called as a triple product. Triple product is also called as a box. And the box can be rotated because this can be written as a determinant. A in first row, B in second row, third row is C. Then ABC is A dot B cross C. It is also equal to CAB. It is also equal to BCA. Like that you can rotate it. You can rotate it because rows or columns are rotated in determinant, and then determinant does not change. So that is ABC, CAB, BCA, all are equal. That is the triple product. Next point, A cross B cross C is nothing but first into last. C dot A into B minus C dot B into A. C dot A into B, C dot B into A. This you have to remember. So correct? This is also another important point you have to remember. Correct? Another remember now, A bar for the problem's purpose, because we are entering to problem within 2 minutes, A and B are two vectors. If they are collinear or parallel, we can write one vector equal to T into other vector. If two vectors A and B are given, they are collinear, then one vector equal to T into B bar. Or we can also write A1 by A2, B1 by B2, C1 by C2. So, two vectors are collinear or two vectors are parallel, then A1 by A2 equal to B1 by B2 equal to C1 by C2, or one vector equal to T into B bar. First. Next, A bar, B bar, C bar are coplanar. Coplanar is also called as linearly dependent. One vector is depends upon the other two. Linearly dependent or coplanar vector means a simple, because we are doing only objective, depth of that is 0. Depth of that is 0 is called coplanar. Whereas if 4 vectors are there, A, B, C, D, are coplanar, then AB dot AC cross AD or determinant of that 4 vectors made into 3 is 0. AB parallel or collinear, A is T into B. If two collinear vectors are there, A1 by A equal to B1 by B equal to C1 by C2. ABC are coplanar, then that is 0. ABCD are coplanar, then also AB, AC, AD is 0. That also you remember. Next one, volume of a parallelepiped. Parallelepiped means like this. Whose coterminous edges are given? Coterminous edges of a parallelepiped are given as ABC. Coterminous edges of parallelepiped are given as ABC. Then its volume is box ABC. ABC are three coterminous edges of a parallelepiped. Then its volume is box ABC. If ABC are edges of tetrahedron, then its volume will be 1 by 6. With 1 by 6 tetrahedron, without 1 by 6, it is called as a parallelepiped. Next, another thing is R equal to A plus TB is a line. R equal to C plus SD is another line. These two lines are non-coplanar, non-intersecting, non-coplanar, non-intersecting. Then they are called skew lines. So R equal to A plus TB, R equal to C plus SD are two non-coplanar, non-intersecting lines. Then they are called skew lines. Then the least distance or the shortest distance between them is C minus A dot B cross D by B cross D. C minus A dot B cross D by mod B cross D. This is called as the distance between the skew lines. Distance between the skew lines. And another thing is a reciprocal vector. A reciprocal vector A dash or A complement is nothing but B cross C by ABC. So these are the major formulas, and there is no end because many formulas are there. And those who want the total list of the formulas, with various problems, various worksheets, you can WhatsApp me 9009994580. Now we'll go to the problems. See, different type of problems I will do. First problem, A bar. A bar is many formulas while doing problems I will tell. A bar is I minus 2j plus 2k. Unit vector parallel to A bar is A bar by mod A. Unit vector parallel to A bar is A bar by mod A. A bar by mod A. This is the unit vector parallel to A. First problem. Problem number 2. There are many assumptions also, logics also will use. Slowly we'll do that. Next, unit vector parallel to unit vector parallel to A bar and B bar. Unit vector parallel to A bar and B bar is, I am repeating again today and tomorrow at 1 o'clock also. I am taking all major methods, I will complete it in vector algebra. So unit vector parallel to A and B is A plus B by mod A plus B. 3i. J cancels k by root of. This is the unit vector parallel to A and B. This is unit vector parallel to A. Next. Unit vector perpendicular to two vectors. Unit vector perpendicular to two vectors is unit vector perpendicular to two vectors is A cross B by mod A cross B. That is nothing but A cross B means I, J, K, 1, 2, 2, 2, 3, 6 and its modulus. After getting, you can write modulus of that. I, J, K, 1 minus 2, 2, 2, 3, 6. Now, I into minus 12, minus 6, minus 18. Because you know determinant plus, minus, plus. We will do like this. Minus 12, minus 6. Next, 6 minus 4. K into 3 plus 4. So, unit vector perpendicular to A and B is this by its modulus. This is unit vector, its modulus. Now coming to fourth problem. Fourth problem, A dot I is equal to 3. Then A cross J dot 2I plus 7K. See here, AI is 3. Then A cross J dot 2I plus 7K they are asking. Now, we can assume theoretically means A equal to Xi, Yj, Zk. But here, by observing itself, A is 3I. Because I know 3, I dot I is 3. Simple. Because we are doing objective. 3I dot I is 3. So, A is 3 from this. Now substitute it. 3I dot 2I 7K. I cross J, all of you know. Always. I cross J is K. J cross K is I. K cross I is J. Whereas you remember A dot B is B dot A, but A cross B is not A dot B is B dot A. Anyhow, I am sending all these formulas. This one. So I cross J is K dot K dot I 0, K dot K 1 20. This is the answer. Next problem. Sigma or better. A dot I whole square, A dot J whole square, A dot K whole square. Previous EAMCET question. Simple problem. A dot I whole square, A dot J whole square, A dot K whole square. So what we will do this? A very simple A equal to Xi you take. Now don't take a big because objective we are doing. Xi by J Zk you have to do, but simple. Mod A root X square X. Now I will write here. X I dot I, X I dot J, X I dot K. I dot I 1, so X square. I dot J 0, I dot K 0. X square is nothing but mod A square. It is a mod A square. So A dot I whole square, A dot J whole square, A dot K whole square is nothing but mod A square. Whereas in the same manner, if I do A cross I whole square, A cross J whole square, A cross K whole square. Let us imagine if they are asking this. Then you will get same method you do, you will get 2A square. I am not doing. Simple, same method you can follow later. It is 2A square. Next point. In triangle ABC, what is AB bar, BC bar, CA bar? In triangle ABC, what is AB, BC, CA? AB according to triangle law vector, this. BC, OC minus OB. CA, OA minus OC. I think this cancel. This cancel. All are cancelling. OB minus OA. This one. OC minus OB. OA minus OC. All cancel 0 bar. It is a vector, so 0 bar. This is another problem you have to do. Next point. Now, one of the two important problems now. Previous mains questions. ABC are unit vectors, then maximum of ABC are unit vectors, then the maximum value of A minus B, B minus C, C minus C. I am repeating again. ABC are unit vectors. Then what is the maximum value of what is that? A minus B whole square, B minus C whole square, C minus C whole square. What to do? See very carefully. This is one of the important. I will square it. B square, C square. A square is mod A square. Already I told. So 2 into mod A square, mod B square, mod C square. 2 into A dot B, B dot C, C dot A. Now 2 into 1, 1, 1. Sigma, because instead of writing 3 terms, sigma I am putting. I will repeat again because this is one of the important problem. Here onwards, all important problems only. Typical and not typical, but important one. A, B, C are unit vectors. The maximum value of this. A square, B square, squaring, squaring, squaring over. A square is mod A square. I already told. A cannot be mod A, but A square is mod A square. So for that I wrote like this. 1, 1, 1, 6. Sigma. A dot B according to scalar product. Mod A, mod B, cos theta. 1, 1, cos theta. Here important point you have to remember is always in a vector algebra, objective purpose I am talking, for a maximum minima, theta is 60 or 120 you can write. So here I will do 6 minus 2 sigma cos 60 or cos 120. Sigma cos 60 is 1 by 2 or 6 minus 2 sigma cos 120 is minus 1 by 2. Always for maxima and minima, sigma theta value will be 60 or 120. So sigma means I think 3 by 2. 6 minus 3, 3. Minus into minus plus 2 into 3 by 2, 9. So this is maximum, not visible. This is maximum, this is minimum. One is maximum, other is minimum. So this is the one of the important problem you have to remember. Next, another thing is AB bar is equal to 3i plus 4k. AC bar is equal to 5i minus 2j plus 4k. In triangle ABC, length of median AD bar. I am not doing because simple only one step I will write. AD bar is add it and by 2 and modulus. I am not doing because it is simple. This is a simple thing. Next point. AB plus AC by 2. So one more thing is A bar, B bar, C bar are unit vectors. All these are the previous sentence questions only. Are unit vectors and A bar plus B bar plus C bar equal to 0. Then angle between A bar comma B bar. A, B, C are unit vectors and A plus B plus is 0. Then angle between A and B. So what I will do, because A, B they are asking, you take C that side. Now square it. I already told A square is mod A square. A cap square 1, 1, 2 A dot B is equal to 1. A dot B is minus 1 by 2. Here not visible, here I will write. A dot B is minus 1 by 2. So I am repeating again, ABC are unit vector and A plus B plus is 0, angle between A and B they asked. So because A and B asked, C I had taken that side and squaring I had done. So I got A dot B. But cos theta I know. Minus of is 120. This is the another problem. Next, one more important problem is, see very carefully, many important problems are there. Few we are doing today, few we will do tomorrow. So another is I plus lambda j plus k, j plus lambda k, comma, lambda I plus k are coterminous edges of parallelepiped are edges of parallelepiped and volume is minimum then lambda. So that means they are asking volume of a parallelepiped formed by these coterminous edges is minimum, then what is lambda? Always volume I told box ABC. Box means first vector. 1 lambda 1 this. Second vector 0. I not there no 0. J1 k is lambda. Here 1 0 1. So three coterminous sides are given, then volume of the parallelepiped is maximum, then what they are asking? Lambda value. For that, I wrote the box ABC. If it is a tetrahedron, 1 by 6 will come. Here volume of parallelepiped as it is. So 1 into 1 minus 0. Lambda minus, second one is minus lambda into 0 minus lambda. I like this I am doing. 1 minus lambda. 0 minus lambda. 1 into 0 minus 1. So very carefully observe it what we are doing. 1 into 0. Lambda into 0 minus lambda. 1 into this is 1 1 minus 1. This cancels. So for all maxima and minima, V dash should be 0. So lambda is 0 null. Always for this not visible. This not visible. Because it's not visible. Here you expand it. Derivative should be 0. V dash should be 0 for maxima and minima. For maxima and minima, the derivative should be 0. So I equated the 0. That you have to remember. Next. After this, derivative you have to do. Sorry. Next is one more typical problem. If A plus B is root 3, C bar equal to A bar, B bar, 3 into A bar, comma B bar, mod A, mod B is 1, then 2 into mod C. Latest mains question. A plus B is root 3, A, B, C are unit vectors, and C bar equal to A bar, B bar, 3 into A bar cross B bar, mod A, mod B 1, then mod 2 mod C they are asking. First of all, always a vector cannot be its magnitude, so always you have to do squaring. Square is equal to 3. A square is 1 because mod A, mod B 1. 3. 2 A dot B is 1. A dot B is 1 by 2. Squaring A square, B square, 2 A dot B is 3. 1, 1. That side I taken A dot B 1 by 2. Here they are asking, this is also given 2 mod C they are asking. So what I will do? Because we can't do A, B, C without magnitude. Always you have to do squaring. Squaring. Two A dot B. 2 into 3. 6 A dot A cross B. 2 into this. 6 B dot B cross A cross B. So before going to this step, I wanted to tell some more things. Remember carefully important things required for the objective. What does that mean? A dot B cannot equal to B dot A. A cross B is equal to minus B cross A. Already known. Whereas scalar product and cross product, you multiply and add, you will get another important. Anyhow, I am giving the list, but even then, because important, here I am talking. A dot B whole square, A cross B whole square is equal to mod A square, mod B square. Next point. A dot B C, I told I can rotate it. But if two terms are equal, any two terms, it will be 0. Triple product in which any two terms are 0, it is always 0. Whereas IJK triple product is always 1. IJK triple product 1 and any triple product if two terms are equal because two rows are equal in determinant, it is 0. So that also you have to remember. And one more important formula, A cross B, B cross C cross A. 2020 question. A cross B cross C cross A is equal to ABC whole square. Another important formula. A cross B cross C cross A box is nothing but A cross B cross C cross A box is ABC whole square. These are the important points. Now, C square I don't know. A square is mod A square, unit vector 1, 1, A cross B. A cross B. So A cross B I don't know. So I will keep as it is for you. And here 2 into A dot B. Here A dot B. This is nothing but A dot A. 2 terms equal 0. Here 2 terms equal 0. Up to this I got it. Now next step is here C square 1 plus 1 2. A cross B whole square from this. A cross B whole square. A square B square minus A dot B whole square. 2 into A dot B is 1 by 2 already. Here. A cross B whole square. A square B square minus A dot B whole square. Otherwise, if from this you find out cos theta, theta value, then sin theta. You can do like that also. 2, 3, A square 1, A dot B 1 by 2. This cancel. Half 3 by 2 plus 1. How much you are getting? Observe it. 1 minus 1 by 2 square. This is 1 by 2 square. Here 1 by 2 only. So 3, 4 minus 1. 3 by 4. 9 by 4 plus 1. 8, 9, 4 by. We can find out. C square is this. Take 4C square. Not visible here. Better here I will do. 4C square is equal to, because 4 after LCM this side, 21. 2C is nothing. What do 21? Like that you can. So remember very carefully. Here I done C square. 1 plus 1, 2. 3 into A cross B whole square. A square B square. 1 into 1 minus A dot B. A dot B is 1 by 2 square, 1 by 4. A dot B 1 by 2. Cancel 1. Here 4 minus 1. 3 by 4. 3 3 is 9. 9 by 4. 8. 12. 9. Correct? So like this you have to do. So this tomorrow at 1 p.m. I am continuing, and after that, today I won't send any assignment or worksheet, etc. Tomorrow after 1 o'clock, vector algebra part 2, all problems only, because all formulas I discussed today, all problems, all typical and assumption problems I will complete it tomorrow, and after that I will send worksheets, formulas, etc. Those who want, this number is mine. WhatsApp me tomorrow after class. You WhatsApp, not now. Okay, we'll stop here, and tomorrow same time 1 o'clock we'll continue.